So guys, if I started that sequence out again, the 2, 4, 6, 8, not the who do we appreciate part, but what will be the next three terms after 2, 4, 6, and 8? So 10, 12, and 14. And what was your reasoning? So you guys were already trying to identify a pattern there by saying, hey, stuff is going up by 2 each time, right? Well, that's really what we're going to look at today, and what these sequences look like, or patterns look like. These are going to be called arithmetic sequences today. And what we want to know is how we can use an arithmetic sequence to describe a pattern. Right? So many times there's numbers that are out there and people will look and find patterns. Have you ever gotten puzzles or brain teasers like that and say, what are the next 3 numbers? What's the pattern? What's the pattern? That's kind of what today is about, all right? Going to be a really nice formula that I think that if you pay attention on the notes today, you'll understand. And that formula applies to every single sequence here, and it makes it very easy for you to write functions for this. But guys, the thing I want to make sure that we don't lose sight of, every function that we've looked at in this chapter has been what type of a function? Every graph, what have you had for every graph? Has it been a curve? Has it been? It's been linear. Everything's been linear this chapter, okay? So don't expect anything to change here, guys. Anytime you see this phrase right up here, arithmetic sequence, this is what I want you to think. Think linear model, okay? Think linear model, because we're still working with linear models. And I want to show you how arithmetic sequences tie in with linear models. Guys, talk to me about slope again, rise over run. If I rise 4 and run 2, what's my slope? 2. It means for every 2 units you move up, you move over 1. Okay? The slope of 2 is like a pattern of going up by 2 every single time. So what I want you to really understand too, arithmetic sequences are really going to tie in well with slope as well. All right, so just maybe some cheater notes up here to help you understand what we're talking about. Okay, so how do we use an arithmetic sequence to describe a pattern? Well, what we're going to end up doing today is writing the terms of an arithmetic sequence. I'll show you that in a second. We're going to look at the graph. Expectation is the graph is what type of graph today? Linear. Okay. Graph arithmetic sequences. And then I'm going to give you a nice formula to help you write arithmetic sequences as functions and then use that to make predictions about certain terms. So, being in the position we're in, how about a volunteer to read to me first of all what a sequence is? Go, Tori. It's an ordered list of numbers. It's an ordered list of numbers. Now that list might have a pattern, that list might not have a pattern. Okay? The 2, 4, 6, 8 had a pattern. Went up by 2 each time. How about this one? 1, 3, 6, 1, 2, 1, 8, 5, 9, 7, 12, 14, 26, 44, 55, 91, 62, 88, 77. What's the pattern? There really isn't one. There probably is one, but I'm not going to sit around trying to figure it out. But it just might not have a recognizable pattern right away. That would still also be a sequence. Okay, how about a term right here, guys? Each number in a sequence. So if I say, hey, here's a sequence, maybe here's a list of numbers, 2, 4, 6, 8, ... or something like that. Each number in a sequence is a term. So my terms are 2, 4, 6, and 8, and so on. Those are my terms. Right? Now the one that we're really going to focus on today is called an arithmetic sequence. And an arithmetic sequence is a sequence where the difference between each pair of consecutive terms is the same. So this idea right here, talking about the difference. In other words, I'll just bring it down here. 2, 4, 6, 8. Guys, what's the difference from 4 to 2, or 4 minus 2 in other words? Up 2. 6 and 4, that pair. Same thing here. Up 2. Every time you make a jump from the one term to the next term, it always goes up by the same amount. That's what that common difference means, okay? And that common difference in this example right here would be that value from the first to the next, for one pair to the next pair. So again, up 2, up 2, up 2. So the common difference basically is saying, I think the best way to do it would write it this way, moving up or down the same amount, up or down the same amount. Moving up or down the same amount. That's all a common difference is. Okay? So take a look at the example of the arithmetic sequence I have down here. First of all, When I talk to you about position, I'm talking to you guys about the very first term that's listed. So in this table right here, position 1, what's the first term listed? 6. Now, I want you to understand something. We're going to start looking at some notation stuff here. This position being 1 right here, they're going to start calling this A of 1. Okay? All that 1 right here means is that's the first term. Okay, A just means what term are you talking about, and that 1 means that you're talking about the first term. So what is the first term here, guys? You said it was 6. Okay, in position 2, what value do you have in position 2? What value do you have in position 2 here? 12. So you would have a difference of, let's see, go from 6 of 12, positive 6. Okay, this is like, when I say position 2, this would be like the term A2. Okay, to go from 12 up to 18, third term, guys, what's my difference? What's my difference? Okay, from 18 to 24, what's my difference? Okay, now they're going to get on this idea here. By the way, if position 1 meant this is term A1 and position 2 meant this is term A2, then 3 would mean, well, it's the same as A3. This is the same as A4. This would be the term A sub n. Guys, can you identify a pattern right here? What are you doing to your inputs to get your outputs? In other words, what do you do to 1 to get to 6? What do you do to 2 to get to 12? What same thing do you do to 3 to turn it to an 18? What same thing do you do to 4 to 24? In other words, what operation would you do to all these outputs, or I'm sorry, all these inputs to get all the outputs? In other words, something to 1 equals 6. Same thing to 2 equals 12. What am I doing to these top values to get these bottom values? Nolan? Multiplying by 6. So if they throw a variable in here and say, hey, I want the nth variable can be found by taking your input times what? Well, 6. Okay. All right, so again, things I want you to understand. If you see an A of 1 like this, this means the term in position number what? 1. A of 2 means position 2. And then the term value is down here. Okay? All right. So that would be an example of an arithmetic sequence, because in that sequence, each time from the first term or from the previous term to the next term, that value goes up by how much? How much does it go up by each time? How much is this going up by each time? 6. What I would say here, guys, is this. The common difference in this right here, common difference is 6. Okay? All right, so let's see how good we are. Guys, in example 1 down there, it says writing the next terms of the sequence down there. First of all, it says write the next 3 terms of the arithmetic sequence. So we need to kind of identify a common difference from term to term. So to go from -2 to 6, and then 6 to 14, and then 14 to 22. What's the common difference right here? Not 6. In this one right down here. Example 1. How much am I going up by, from -2 to 6, guys? 8, right? 6 to 14 is up. 8 more. 8 more. So what's the next term going to be? Okay, 8 more on to 22 would be 30. Okay, and it says write the next, well, it says next tree, that should be 3. Sorry. Should be next 3 terms of the arithmetic sequence. What's after 30 then? 38. Everybody understand why? Just going up by how much each time? Going up by 8. And then after that, what have you got? 46. Okay. Okay. And we don't have to list any more.
Teachers, please release the students going on the academic decathlon. Teachers, please release the students going on the academic decathlon this morning.
Good. Any questions on the first page? All right, let's roll on page 2 here. Let's look at what an arithmetic sequence looks like graphically here. So it says graph the arithmetic sequence up there, 2, 5, 8, 11, 14. First of all, what do you notice, guys? What's your common difference in that? It's 3. Okay, I'm gonna start to kind of do things notation-wise correctly for you here and get you to understand what it is that we're really plotting here. But guys, the first term right here, what is my first term? 2. So I'm gonna make a table right here, like this. And I'm going to go ahead and put in A of n, like this. That just means my position. What position is the term? And then down here, this will be your term. What value is the term? Okay, so term 1, A of 1 was what value? 2. Term 2 was what value? A of 2 was what value in this sequence? 5. Okay. The third term, A of 3, what's A of 3 equal? 8. A of 4. And finally, the last term that we have in this is A of 5, which is what value? Okay. So guys, if they give you a sequence right here, I think it's a great idea for you to go ahead and make a table like I have. Because when you look at this graphically, that's what's happening. So, here's what this is going to look like graphically. Okay, all they did is give you a sequence right here. They didn't give you any inputs, but that's where the terms come into play. Basically, what you have up here is the first term, which was what value? This is like the first term is 2. This is like finding the point 1, comma 2. Okay? So over here, I'm going to put down on the bottom down here, I'm going to write this as A of n. Okay, well, and maybe I don't even want to do that. I don't even want to do that. The way I want to write this is just your n value down here. Okay, that's that small subscript down here. Okay, and then over here I'm going to write down, you know what, this is your term value, which is A of n, like this. So guys, when the n value here is 1, what do we get out for a term value? 2. So we really plot the point 1, comma what? Right 1 and up 2, and I'll do my best, okay? Whoops, I even screwed that up already. All right, right 1 and up 2. You guys agree with that on that graph right there?
Yeah.
All right, well, the next point I would plot then, given a sequence like this and a notation form like we've formed here, 2, comma 5. When n is 2, or our second term, we get a value of 5. So right 2 and up how much? 5. Boom, there it is. Okay, the next one would be 3, comma what?
8.
So I count right. 1, 2, 3, here's 5, 6, 7, 8. Next term is 4. 4, comma 11. Fourth term is 11. Plot 4, comma 11. I'm going to blow this up a bit. I'm having a tough time seeing this up here today. So right 4 and up 11. Would that be right here, guys? Everybody agree with that? And then finally, what's the last one right here? My fifth term is what? So this would be like find the point 5, comma 14. So right 5 and up
14.
Okay, so there's the plot of that right there. Guys, quick question. What do you notice about that arithmetic sequence that gets plotted? What do you realize about these points? It goes up. It's a line. It's linear. Oh. So this whole idea of talking about slope-intercept form, point-slope form, linear models, how we tie in arithmetic sequences, and we've got the relation that any arithmetic sequence has to be what?
Linear.
Has to be linear. Right? Has to be linear. So right here, what do you notice? Well, the plots model a linear function. Oh, I love the word. Oh my gosh. I'm going to do a backflip. I don't want to hurt myself. Okay? Model a linear function. Models a linear function. So if I had to say, hey, come up with some kind of a core idea about arithmetic sequences, you would say a sequence is arithmetic if its graph is a line, linear. Okay? Hey, by the way, what's the slope of this line from point to point? Rise up and run how much? Rise 3 and run what? 1. Rise 3, run 1. Slope's 3, right? What was the common difference from term to term? What was the common difference to go from 2 to 5? 5 to 8. The slope and the common difference are the same thing. So if you ever hear me use the phrase, hey, what's the common difference in here? You're just looking for a what? Slope. You bet. You bet. All right. Hey, determine if a graph represents an arithmetic sequence or not. I'm going to put a graph up here. This is fun. You want to do the same thing. It'll be cool. All right. Obviously, you don't share the same excitement that I have for this. I don't really know what's going on right now. Okay. It says, does the graph represent an arithmetic sequence? Explain. I'm going to make a graph right up here. I'm going to start at the point 1, comma. I'm going to start at 1, comma 5. I'm going to go 2, comma 7. I'm going to go 3, comma 9. 4, comma 11. I'm going to go 5, comma 13. And finally, I'm going to go 6, comma 14 right here. I don't know. I'll show you why here in a second. So how many plots did I make up here? So I'm going to write A1 for my position all the way through A6. A1, A2 steak sauce, A3 steak sauce, A4 steak sauce. Okay. Never mind. I do too. Does it look like 91, 92, 93, 94, 95, don't they? Understand their A's. Understand there's A values, okay? All right. When our A value was 1, or our first position, we had 1, comma what listed, guys? 5. I'll put the values down here. 5, 7, 9, 11, 13, and 14. Okay. First question, the sequence that I've got there, arithmetic or not arithmetic? No one, you're shaking your head no. Tori, you're saying no. I'm hearing a lot of no's. Why is this not arithmetic? What's one reason? Okay, so you're looking at the table right down there, right, Tori? So from term 5 to term 6, the common difference instead of, looks like the common difference all the way up to term 5 was 2. All of a sudden from term 5 to term 6, what's the difference from 13 to 14, kiddos? 1. Does common difference stay the same or consistent throughout that whole pattern? Absolutely not. Okay? Well, maybe you didn't want to look at the table. Mason, I heard you say something that was interesting. Why is this not arithmetic? Maybe you were looking at the graph, it sounded like, when you made your comment that I heard you say. What's the problem with the graph? It's not going to form a straight line. It's not going to form a straight line. All those points put together, not linear. Okay? So does this represent an arithmetic sequence? We're going to say no and explain. Well, one reason we had was from Tori. Tori, what was your best definition again? The common difference is it okay if I write CD? Is that okay, guys? Common difference is not, what's the word you want to use? Not the same all the way through. Can I say consistent? Is that okay? It's not consistent the whole way through. So the common difference is not consistent all the way through. So what she's saying is, hey, 5 up to 7, plus 2. 7 to 9, plus 2. We're still good, right? 9 to 11, plus 2. 11 to 13, plus 2. Finally, right here, this is bad. This is bad. All of a sudden, the common difference is what? Okay, that's a problem. That's a problem. All right. Mason's reasoning was, I'm not even going to look at the table. I'm going to look at the graph. This is not going to be an arithmetic sequence because the graph, it was linear for a while, wasn't it? And then it took a turn right there, right? It was here and then it turned. So the graph is not linear. All right, good, you guys. Very good. Any questions about this so far? Any questions about this so far? An arithmetic sequence, you have to have the same common difference the whole way through. All right, any questions on those first two pages? All right, page 3 is where things get pretty interesting. Pretty interesting. And honestly, if you can understand this formula, it would be pretty easy for you. Okay. Got it? All right, page 3 here quickly. Okay, example 4 says talking about, you know what, we're going to find the nth term of an arithmetic sequence. We might have a sequence that starts out like this right here and goes on for a long, long ways. I might want to say, I want to know what the 1,000th term is. I want to know what value is going to be 1,000th in line. Okay? And do you want to write all of those 1,000 values down, or do you want to be able to get that quickly? Get it quickly? You don't want to write 1,000 values down, Nolan? Why not? Take a long time. We don't want to do that, okay? So here's what's going to be most important for us in this section today. If you notice right here, kiddos, there's a big box here for a formula for any arithmetic sequence. You need to highlight this, do what you need to do, but this is probably the most important thing today. It says formula for arithmetic sequences is given by the following, okay? This is highly important. You guys remember your point-slope form formula? Remember your point-slope form formula? This is kind of a variation of that. It's pretty much the same thing. But guys, finding the nth term of an arithmetic sequence. It says write an equation for the nth term of an arithmetic sequence given to you as 7, 3, -1, -5, and then find a of what? 30. We want to find the 30th term in this thing. All right, now I don't want to list out 30 terms because we can use some things that are here first. But here's what we're going to do, guys. I'm going to go ahead and talk about my position value. So I'm going to call this A1, A2, A3, A4. Okay, I'm going to skip some values all the way up here. And I'm not going to worry about what's in here, but what I'm going to do is I'm going to come clear over here and write down A of, what term do we want to find? 30th. I want to know what the 30th number in line is going to be. Okay. Guys, right here, formula for any arithmetic sequence. It says the nth term right here, the one that we want, any term. The nth term right here is equal to A1. A1 really being which term? A1 is going to be the position 1 term. So what's the first term in this sequence right here? 7. Okay? 7. I'm just going to put down all the terms they gave us in here. Second term was 3. Third term was -1. Fourth term is -5. Okay. It says the formula for arithmetic sequence is equal to A of n is equal to the first term times your n value minus 1 times d. What do you think d represents? What did we talk about on the last page? Somebody say it. It's called the blank blank. The common difference. Good. I'm going to write down right here. D is your, you might want to jot this in here like this. D is your common difference. Okay, let's see if we can't write a formula for this thing. First of all, go from 7 to 3, 3 to -1. Yep, moving down 4 each time, aren't you? So what's the common difference here, kiddos? -4. I'm going to jot this down in this right here, guys. Your D value is -4. D is -4. Okay, I'm going to kind of split this here a bit, like right here. First thing we want to do is write an equation for the what? What's it say? The nth term, right? Okay, you're just filling stuff here in this formula. So here we go. Here we go. This is the formula we need to write right here. So here we go. Guys, A of n. I don't know which term we're talking about. A of n is going to equal the first term. What is my first term, guys, in this sequence? 7 times n minus... Oops, I think I forgot a plus sign in there. Gosh darn it, I did. I messed this up, guys. I messed this up. Guys, there's supposed to be a plus sign right in here. Between the A1 and the n minus 1, get a plus sign there. Okay, really big mistake on my part. Did you get a plus sign between the A1 and the n minus 1 times b? Okay. So that's going to be, let me back up here quickly. Make sure there's a plus sign in there. Gosh darn it. That's bad. That's just very bad. All right, what's your A1 value again, kiddos? 7. Plus. Gosh. Okay. And then you're just going to put in n minus 1 times, what's the d value now, guys? What is our common difference? Negative 4. Everybody agree there? All right, all y'all got that? Okay, so here's the deal. We're going to manipulate this a little bit. We have negative 4 times n minus 1 right here, in which case, what property could I apply right here? Which property could I apply right here? Okay, so A of n is going to equal the following. It's going to equal 7. Okay, what's negative 4 times positive n? Negative 7 times positive 4 from minus 4n. And then help me out here. Negative 4 times negative 1 will be what? Plus 4, right? Okay. Everybody with me on this? All right, looking at what A of n is equal to, how about the positive 7 and the positive 4? What could you choose to do there? Do what? Couldn't I add the 7 and the 4 right here, combined like terms, kiddos? So finally we end up with a formula for the nth term. It's equal to negative 4n plus, what's 7 and 4 make? 11. Now guys, when I get to this point right here, that negative 4n plus 11, doesn't that look like slope-intercept form in a way? What's the slope, guys? Same as the common difference. And if you were graphing this, what would the y-intercept be? Now I want to show you something, okay? Because the first thing we've done is written the equation for the nth term. Okay, we can find any term. I can find the 1000th term in this right now. Okay, but let me just show you how this works. Term 1, what's the n value right here, guys? 1. Plug 1 in for n. What's negative 4 times 1? Negative 4 plus 11? Careful. 7. Isn't that value right there? Isn't that value right there? Plug in your n value of 2, guys. What's negative 4 times 2? Negative 8 plus 11. Does that match the output of 3? As long as you keep plugging these n values in right here, you're going to get a term value for this. So what term are we trying to evaluate in this problem now, kiddos? A of 30. So really, what's the n value that we're going to plug in? All right. So once you've got this formula written, you simply come back down here and say, you know what? We got to find A of 30. And A of 30 is simply going to equal the following. It's going to equal, use this function, -4. What do you want to substitute for n right here, kiddos? 30. -4 times 30 plus 11. So it'll be -120 plus 11. And we punch that up, you should get -109. So the 30th number in that sequence is what value? -109. Okay? Guys, very crucial. Make sure you get the plus sign there. Did I talk to you guys about forgetting stuff, about forgetting things? Because when things go bad, you've forgotten about it already. Did I talk about that this morning already? You guys have forgotten what I talked about already. You forgot that I forgot that you forgot, right? What? Guys, I want you to try one on your own. Okay? I want you to try one on. Now, guys, real quick, what was the first thing we found in this? Common difference. And then we plugged in a of n. We said that's equal to, where does 7 come from, guys? It's the first term right here, then the n minus 1, and then times your common difference. Work it a little bit to get into slope-intercept form. Once you get done with this, plug in the n value for the term that you're trying to find. So here's the sequence, guys. 6, 9, 12, 15. I want you guys to, first of all, write a formula, write an equation for the nth term, like I did right down here. And then once that's written, what term am I asking you to figure out? What term am I asking you to figure out here? 60th term. Okay? So take a minute and give that a shot. Again, the formula is what's most important up there. By the way, what's the common difference there? What's the common difference there? Okay. Go ahead and give it a shot. I'm going to work on it up here while you are, and then see where we're at. Hang on 1 second.
So is that like a meditation?
Mm-hmm.
I mean, like,
What's a positive 6 minus 3?
3?
Plus 3, not minus 3, right?
Wait, wow. What does it take? It's negative 1.
Right, but when you get to this part right here, you have the 6 out front, plus 3, and minus 3, right? 7, 3, and minus 3 came from distribution, right? So you have 6 minus 3, which could combine to negative 3, but plus 3.
Oh, yeah, no, I know.
Now evaluate, okay?
Alright.
I'm going to have a value. Nolan, what did you end up with? Yep. 183. Am I hearing any other 183s out there? Let's check this out. Let's check this out. Whoops. All right, guys, check out my work right here. The first thing that I identified down here on the left was that D is equal to what value, guys? 3. Okay? D is equal to 3. So I came right up to here. And I said, you know what? The nth term, A of n, is equal to this formula right here. This A1 up top is the first term. So in my sequence, what is the first term, kiddos? What's the first term? 6. So I go 6 plus, then in parentheses, that n minus 1, part of the formula, times, where did this 3 come from right here on the end, kiddos? Uncommon difference, right? Okay. Now, I have to take 3 times this quantity of n minus 1. So when I distribute, we have the 6 out front. What's the 3 times n right here? 3n. And what's the 3 times the negative 1? Yeah, minus 3, wouldn't it? Okay, in which case this positive 6 and this negative 3 would combine to a positive 3 in the end. So down here in red, A of n is equal to what? What's it say here? 3n plus 3. That's your formula. Now, what are we trying to evaluate in this problem, kids? A of 60. So what value am I plugging in for n down here now, guys? 60. So it becomes 3 times 60 plus 3, part of the formula that you came up with. And then this is 3 times 60, which is the 180 plus the 3. 60th term in this sequence would be what value? 183. Okay. I'll wait till you have that down. Just give me a show of hands when you've got that down right now. A lot of formula stuff. A lot of formula stuff. By the way, if I graph this, what would the slope be in this problem? 3. Up 3 for every change in 1, okay? All right, very good. Anybody need more time with that? Whoops. All right, last page then, kiddos. Like this problem. It's a good one. Okay, it says Juan saves $12 the first week of the year. All right, I should start doing this. But Juan saves $12 the first week of the year. He's going to increase the amount he saves each week by how much, guys? By $4. First thing it says to do, write an arithmetic sequence that represents this situation. When they say write an arithmetic sequence that represents this situation, they're saying write an equation for the nth term. Okay? So here's how this is going to work. Just looking at this right here. In his first week, how much is he going to put away? $12. So that's like saying my first term is 12. Okay, how much more is he going to put away next week? So totally, how much will he put away next week? 16. Let's just do a third week. How much is he going to put away the third week, kids? 20. All right, first things first. Are you recognizing a pattern here to begin with? What's the pattern? Going up by 4. So the question becomes, what's my common difference? Well, what is the common difference here? It's 4, isn't it? So I'm going to write this down. D is equal to 4. Right? So I'm going to write the formula down here again. A sub n, the nth term, is equal to the first term plus n minus 1 times our common difference d. So let's write our formula first. What I'm going to do up here is I'm going to label this. This was the week. Week 1, week 2, week 3, and this is the amount of money he's saving right there, 12, 16, and 20. All right, here comes the formula, A of n. What's the first term, kiddos? What's your A1 value? 12. So take the place of this right here, you're going to have 12 plus the n minus 1 times d, where d represents your common difference again. So what is that value? Okay, help me distribute on the right there then. It'll equal 12 plus what? 4n minus. Okay, how about the 12 and the minus 4? What's that going to combine to?
8.
So A of n equals 4n plus 8. Okay. A of n is going to equal 4n plus 8 there. Now, it says graph the situation. Well, what's the first point I would really start graphing here? 1 comma 12. My first week of savings, $12 put away. Okay, so to graph this, and we're only going to graph so much. But the first graph, 1 comma what? 12, which would be right about here. Yes? No? What would the next point be? What would the next point be? So right 2 and up 16, there's 15, so 16 would be here. And then the only other point I can get on here is 3 comma what? 3 comma 20. So here's 1, 2, 3, all the way up to 20. Guys, just looking at that right there, does that appear to be linear already? Okay, so 2 questions. Number 1, the points that we plotted appear to be linear, correct? The equation I came up with, does this appear to be slope-intercept form? Guys, if I back down 4 and over 1 right here, does that get me a y-intercept of 8 right there? Which is what's in our function here, right? So if this line was drawn, this would cross the y-axis at 8. If I go down 4 over 1, down 4, no over 1 again, that puts you at that value of 8. So everything's relevant. We're in good shape here. So guys, the part I want you to be very careful about here before we end today is part C. Part C says Juan's goal is to save how much money, guys? 68. Now, guys, this n value up here represents the number of what? Weeks. So this time right here, what 68 is representing is not the number of weeks. He's not saving for 68 weeks, is he? He wants to know when he makes $68. So the way you're going to solve this right here is to let A of n equal 68. They're basically saying, how many weeks is this going to take for him to put away a $68? All right? So here's how you solve this. This is your function right here. Is 68 going in on the left side of the equation or the right side of the equation? So we're going to set 68 equal to what, kiddos? 4n plus what? Okay. And then when we solve for n, n's going to represent which week you put away $68. So I'm going to subtract 8 first. $60 will equal 4n when you subtract 8. So 60 divided by 4 is 15, right? So which week will he put away $68? 15 weeks. So week 15, he saved $68. Couple things, guys. Everything here really new for you, but don't lose sight. There's a lot of tie-ins to linear models here. The common difference is basically your slope. The end value is the position. Which term are you putting in? The first term, the second term, whatever it might be. Okay? Probably going to have a lot of time to work on stuff tomorrow in class. So make sure you have 4.5 wrapped up for 4 o'clock tomorrow. I did send 4.6 out today, so if you feel like you want to get started, go ahead. But that won't be due until Thursday for you. Okay? Questions at all, kiddos? You guys, good job today. Yeah. This is the last section of chapter 4 with linear models right now. Okay?